Good afternoon. Thank you for hanging out with me on a Saturday afternoon. I know it's kind of busy out here, a lot of parties going on, but I appreciate you being here. So today I want to talk a little bit about how you can get started with geospatial, either from a software perspective or from a data perspective, just in general, anything to do with maps and map data. My name is Svrcek. I'm a software engineer, project manager. I put geospatial expert. I couldn't figure out what to call myself from that perspective. A little asterisk there, because what is an expert? I was toying around with aficionado, but it sounds like, like I'm recommending wine pairings with your map data. So I guess what makes me an expert, I spent 10 years in the Army as a geospatial analyst, and then I've been with RGI for 10 years now doing geospatial software engineering and consulting. So this is what we're going to kind of go over, just the why, what, all that kind of stuff, talk about different data services and some example applications and software available. So why geospatial? Because it brings meaning. Because without geospatial, you just have information. And not that information isn't important, but for instance, let's say I said they're going to drop bags of cash from an airplane.
Where?
Right. Exactly. So if I said they're going to drop bags of cash from an airplane in Amherst, we'd all be outside. Come on. And so that's what I mean. And kind of conversely, map data without information is kind of useless, right? If I just said, Amherst, it's okay, that means nothing to us. You can almost do that with few places except Las Vegas? Yeah, okay, I get what you're saying, So in general, geospatial is so important to bringing context to your site, your services, your users. People want to know how this affects me, and I am right here. I always am. So what is geospatial data? I joke, I say everything, but really everything that has a location with it. And really that's just an opportunity to enhance that information with other things. Geospatial professionals like to joke that eventually everything comes around to geospatial. And if it doesn't, it should. And under products and services, you should always be kind of thinking about, hey, how could I incorporate geospatial into this now or later, either a map to get your users to your store, or how can I find out who's using my data? Eventually, it all kind of comes around to locations. So a quick start to getting started with geospatial is just don't do it. With anything with software engineering, try not to build your own solutions. As we'll see in a couple slides, there are so many gotchas with a lot of this stuff, and I want to make it as easy as possible for you. But in general, if you have a site and you want to kind of incorporate maps or map data, locations, I recommend one of many other services that you can just kind of lean into and get started. And we'll talk about a variety of services, and we can kind of always come back to some. I only list these because they're very, very popular. There's a bunch of other companies, obviously, that have very similar services available. Just as a trivial example, here's how you could use, say, Google Maps to load essentially some location data for this conference, right? So you can just plug in an iframe. I'll leave it to you on the security implications or the site implications of that for you. But again, a very small snippet once you get started, and then you can have an interactive map on your site. And then you don't have to have users bounce from your site to go to a Google Maps. You can kind of keep them in place. They could say, cool, I see where this place is, where I am, and I can keep on browsing this particular site if I want to. So to get started, we have to talk a little bit about geography. There's always a relevant XKCD. I like this one in particular because I love maps. I'll let you take a look at it. But I bring this up because this problem is one of the biggest problems when you're dealing with map data and trying to build map programs. The challenge of what kind of projection I'm using, what kind of coordinate system I'm using. And it just comes up over and over and over again, even in these examples that we will see. It causes a variety of problems. Uh, for the record, I'm a PC fan myself. So more about that. So projections are essentially how we want to lay out our map, right? Like in that XKCD comic, he's like, "What's your favorite projection?" And one of them is like a globe. He's like, "Ha ha ha! Yes, very clever." Because eventually we have to figure out what kind of reference system we're going to use. The two systems that I showed earlier are typically broken down into a geographic coordinate system, which is measuring distance on your map by angles. So if you imagine, instead of saying, "Hey, how far away is that light from that light?" and saying, "Oh, that's about 4 or 5 feet," you'd say, "Oh, it's 10 degrees apart," and then just using Cartesian coordinates. And so a geographic coordinate system will use angles or degrees, like you may be familiar seeing with your north, south, east, and west. And a projected coordinate system will use kind of those Cartesian coordinates. Sometimes when you see them, you'll see you see this number system 19 and 25 1. That's basically they break everything out into like a grid, and then you have a subgrid, and then everything is just basically you go this way, you go that way, and that's what you get. You just have to be careful with what you're doing. In general, if you're not sure how to start with geospatial, like which projection you want, 4326 is a good way to go. It's relatively accurate across the entire world. And it will keep the fidelity of the information. If you go with the projected coordinate system, you may it can be a little bit more challenging to kind of go back the other way to keep that information. All right. So the next step is to start with the viewer. QGIS is a open source, free to download viewer to be able to view a variety of services and data. I say start with the viewer because if you're trying to figure out if something's working, these are kind of batteries included, made for end users. So you can throw a data set in, see how it works. If you created your own geospatial service, you can try to tie it in, and you can figure out, hey, is this actually working like the specification intends it to, or how a user might actually use it? If you don't understand like what kind of network calls to make, you can use something like QGIS, add a service in. It will give you that example network call, and you can plug it into your application or whatever you might need. If you're like an analyst or a researcher, you'd use something like QGIS to be able to open up those large data sets and then do different types of query on your data to find out whatever relevant information you want. This year, I'm sure it's going to be a lot of election information or something like that for map people. I add ArcGIS Pro as well. ESRI is essentially the Microsoft of geographic data, if you will. They've been around for a number of years. They're kind of the one of the de facto standards. You'll see them kind of around everywhere. During COVID, Johns Hopkins had a dashboard up, and that was hosted by ArcGIS Online, and they make a variety of services. It's not a super cheap application, but if you're working with a client, typically they'll float you a license, or maybe you could work with ESRI to kind of get something available to you. So data types. There's a variety of kind of fundamental types of data that you would be working with. Vector are your roads, your like house locations. Rasters your imagery. Elevation, I added here. It's essentially a type of raster data, but it has floating point data, so you can see specifically heights and stuff like that. When it comes to services, they'll often break it out specifically so that you can augment your other data sets with it. I often say, if you're trying to work with geospatial data, having a good vector data source, having a good raster data source, and having a good elevation data source is a kind of fundamental to doing your analysis. I also added point cloud and mesh data on here. They're becoming much more popular these days with self-driving cars and things like that. Point cloud data is when you have, say, a LiDAR sensor that will ping different locations, either from top to bottom to get like an elevation, or in the case of, say, self-driving cars, the environment around you. It will, send out a beam of light, and then when that comes back, it will record where that is, and you'll get this big old cloud of data that you can then use to assess a variety of things. And then mesh data is kind of what you would expect to see in like a video game. Your geometry shapes that you can then see, the actual 3D buildings or whatever it is that you're trying to represent. So this is a bunch of nonsense about points. I just wanted to kind of give a good example here. I didn't know how many points would be a good example of a point. 2 seemed like too few, 4 seemed like too many, but a point is exactly what you think it is. It's kind of the most fundamental, like for most people when they're dealing with these types of data sets, this is all the further you have to go. You create your database, store your data like that, because you're typically just want to know where something is. And one of the things I'll say is I have different text representations on here for geospatial data. When you start storing your own data sets, I really recommend you use actual and we'll get to this a little bit more in data storage, but use like geometry blobs or types or whatever it is that your system supports, because there's all kinds of other gotchas when it comes to I'm just going to put like a column of latitude data and a column of longitude data, and it's all going to work itself out. You can run into a lot of issues there. Ideally, you would have some type of tool that would store your geospatial data as a geospatial location, and then you can do all kinds of fun geospatial things later on. Again, kind of just rolling through the different types. I would call these lines, I tend to call them lines, but they are line strings to get really persnickety about it. A line would be any point-to-point segment, and then the line string is multiple points, multiple line segments, if you will. I know those ones look like polygons, but again, I add them here specifically because the specifications will say this could be a line or it could be a polygon. It depends on whether or not it counts as filled or not. And again, these are they can be kind of gotchas when you're dealing with the data sets. You may be looking at something and you think, this is a polygon, I can treat it like a polygon, but you have to specifically say, no, this is a polygon or this is a line, just to disambiguate what you're trying to deal with. So then you have polygons, again, pretty straightforward, just connected line strings. You can have holes in your polygons.
No triangles?
First and last point are the same. So a triangle is 4 points.
Uh-huh.
Yeah, right.
3 points.
But there's a dupe, so there are 4.
Yes. Yeah, you gotta end at the
Right, so that's an explicit additional point.
Right. So that example there for the structure would be a triangle.
Yeah.
I didn't put a picture of a triangle on here, but yes.
Yeah.
Yep.
Do you have to explicitly specify the last point?
Yes. Yes. It depends on what you're doing. One of the most common specifications for indicating polygons is by the Open Geospatial Consortium. It's called the Simple Features Specification or Standard, and they say that it has to be the last point. I refer back to GeoJSON a lot because it's pretty straightforward. They took a lot of the ambiguity of, so OGC had a standard, and it had a lot of different things that you could do with it. And then when they put together the GeoJSON specification, they said, hey, look, you can do all this stuff, but let's just really wind it down to a key subset of expectations. Because when you want people to be implementing a standard or to be able to deal with something, you don't want to have a ton of edge cases. And so when they wrote that, they said specifically that the endpoint has to match the beginning point to disambiguate.
So you can't infer the last one?
It depends on what type of specification you're using, but not typically. The last point is the is the,
I mean,
the
you
first
could, but that would be a different data specification. It's not the standard
Yeah.
data specification.
Which is an interesting choice for why they would pick that for specification.
Yeah, I know, because like when you do like a, like if you some specs when you deal with just like triangles or whatever, you just assume that it's like this. I don't know. I can only assume it's to free up ambiguity on. I don't know. I don't disagree, but I don't know. Who knows? I'm sure there's some edge case for why that is. Why they chose to do it that way, but.
Yeah, I think that's
what it
probably
is.
the ambiguity and trying to remove any sort of possible ambiguity.
Or maybe it's for convenience. You want the vector class to extend the
Oh, that's interesting.
line
Yeah.
class.
Uh-huh.
Oh yeah, that would make sense too. And so then you have those core geometries, but then you have multi-types, which is those geometries, and like you can have multiple lines, line strings rather, as an array, multi-line strings, or you can have multi-geometries, which are kind of all of them mixed together. You can have feature classes. And features. So features are basically a geometry with data associated with it, and a feature class is just a bunch of features. You have a list of features. So here are various file formats and services for sharing and getting vector data. I'm not going to go through all of them. I have them here as a reference, if you will, for just the different types of things that you may have to interact with. Here is probably one of the most important things when dealing with the data sets or the gotchas. So if you're ever dealing with vector data, one of the common examples you have is getting too many features. So you'll go to pull in a service, and it just seems to be missing something. That's because typically, so that you don't pull too much data from a service, like. So you say, I want all of the points in the United States. Well, that would be just too much burden on a server. So they said, hey, you can only get like 200 points at once. And so it's just a typical like kind of either pagination issue where you have to make multiple requests or whatever. But a lot of services don't do a good job telling you that that's an issue. Like it might not throw an error or whatever. And so you just kind of have to pay close attention to that. Too detailed or not detailed enough. So this has to do with how many points are on your different polygons. Like if you had, say, a feature of the United States of America, the boundary of it, that may be just an incredibly large polygon. And so if you're trying to show that on a map, you sometimes have to generalize that feature, which means take that entire polygon and try to go from 10,000 vertices down to, say, 1,000 vertices. You'll lose the resolution of the feature, if you will, but it'll load much faster, and for the most part, it just doesn't matter. The anti-meridian and other misrepresentations. So again, talking about ambiguity, you have your international dateline. That can cause issues with certain client software or APIs that may not know how to deal with it correctly. So basically, again, like if you imagine you put a point in, say, Hawaii, and then you put another point in Indonesia, do you want that to cross the international date line, or do you want it to go the other way? It's not necessarily clear what you want to do with that line. And so typically what a specification will say is, if you do that, we're going to assume that you want to go all the way from Hawaii over North America, over South America, over to Indonesia. If you want to go across the international date line, you should make two different lines. One from Hawaii to the international date line, one from the international date line over to Indonesia. And that clears that. Other issues you might have is missing indexes. Basically, if you're trying to query data sets, you might have to build indexes or whatever. Incorrect projections. So we talked a little bit about geographic coordinate system projections. So if you are using one type of system to store data and you're trying to display that in a different way, now that request has to take that and cut out maybe an image or cut out a part of the features and then convert them into something else and then display them. Your viewer, your server, it's more work on it. It's going to take a lot longer. The last issue is no cartography. So cartography is how pretty we can make the maps and how useful they are to us. If you are missing cartography, that it can be almost useless to view the data in most cases, either because it's going to request, again, all of the points in the United States when you're just trying to view, say, interstate highways, or wanting to view houses when you're all the way zoomed down.
What would the cartography provided look like if what is that in terms of getting data from the server if it were provided?
So your client, like when you have a map file and you have the cartography, you have just various rules for say like, hey, when I'm zoomed in, like when I'm this high, like on the map or whatever, there's specific queries for each of those layers. So it might be, hey, I only want these types of features or whatever. A lot of times to support that, they'll break out your data sets into different themes, if you will. So hey, here's a data set of just houses at or roads or whatever, and then you just choose which one of those you want to show at those levels. Is that?
I think so. Yeah.
Okay. So raster data, pretty straightforward. It's a picture, an image. You see it all the time. Google Maps. You view the maps. Google Maps, even though you can see the roads and everything, that is raster data. They rasterize and serve out the little pictures because it's much faster to do it that way. Point clouds. I think this kind of stuff is super cool. Basically, here you have an overhead sensor that shoots LiDAR down to the ground, collects the information. Here they have it broken out by the type of data, and so you can actually then do analysis. You can turn things on or off. You can do a bunch of cool stuff with it. Just fun to look at. And then mesh data. So here's an example of some extruded buildings using cesium, but you can also see this on Google Maps if you've never tried it. It is super cool.
What is cesium?
Cesium is a open source map library that can handle object files and different types of 3D data sets. They also have a service called Cesium Ion where you can pull down different types of models and things like that.
Thanks.
Yeah. All right. Data storage. So I said I would kind of circle back on this. I have PostGIS, PostGIS, and GeoPackage up there because they tend to be kind of my favorite. They are open source. They are pretty well regarded. I listen to a lot of different podcasts about either geospatial stuff or software in general, and a lot of times when people are dealing with geospatial systems, they'll kind of come back and say, yeah, like you kind of can't go. I don't say you can't go wrong with PostGIS, but it's a pretty good safe choice if you're like, yeah, I need to do something with this. I have here just a model of archery indexing. Some people don't realize. They're like, oh yeah, they don't realize that you index geospatial data, and that's how you get faster responses. And here you have a kind of a good example. Geospatial data, if you've ever looked at a map, it's very sparse because you have it tends to be where people live, and so cities are very heavily populated, and so you just have to have an index system that will kind of, if you had just like an equidistant page size for each one of those things, you would end up having tons of pages that were empty and then tons that were just overpopulated. And so using something like an archery, which most systems like PostGIS and GeoPackage or SpatialLite will support. GeoPackage is just a version of SQLite 3, so it's you can view them on like mobile devices. You can build them into your into your web app or whatever without the need of a separate server. Here I have a geohash representation. So geohash is a way to take coordinates, like so your two-dimensional coordinates, and converting it to like an ASCII string. This can be a great way, like let's say you don't have a geospatial data set like already set up. You can download some type of geohash library, and you can then create a column to kind of create like a geospatial index there. Things like any type of like NoSQL or document store like MongoDB, Elasticsearch, use something like that to kind of index their geospatial data sets because of the way that those systems work and the way they index their data and the way they do search. So geospatial services are what you'll probably most commonly use as an end user to get and view your data sets. You can go out there, you can find these services available, you could take the URL, you can plug it into your map software, and you'll get all of your the data that you need, your base maps, your lines, whatever it is. So geocoding is probably one of the most common ways most end users interact with geospatial data on a day-to-day basis. If you go to Google Maps and you type in a place, it will convert your words into a location, and then it will take you to that location. You can use it for a variety of different things throughout your services, and it's super easy to be able to add to an existing application. Reverse geocoding is the exact opposite. Again, super helpful. I'm right here, what's around me. And a gazetteer is just a list of places. So OSM, who's on first, things like that. They're just, hey, here's a place, here's where it is. Those get used to search for things. Nominatum is based on OSM. Paleus is an open source service that uses a variety of data sets that you could potentially stand up yourself, although it is a ton of data and a bunch of services available. I list here a bunch of geospatial libraries. So you'll see if you ever deal with geospatial stuff, GDAL, Geos, Proj are kind of the basis of a lot of them. They are C++ libraries, so it does complicate your build tooling a little bit. But they're kind of what everybody uses. QGIS uses them under the hood. Even like ESRI and stuff like that use them for certain things. Web development, so I have over there a variety of different web libraries, OpenLayers, Leaflet. So if you want to add a map, you would add something like Leaflet, you get your map, you plug in your services, and then you could rock and roll from there. What good is knowing all of this stuff without actually having data? Here's a variety of different data sources. OpenStreetMap is the most popular data source for geospatial software. It's used for almost everything. I don't say it's used for almost everything, but people who build data sets will typically pull from it because people all over the world are constantly updating OpenStreetMap. Whenever there's a humanitarian crisis, there's like a team called the Humanitarian Open Source Street Map team who will put together map teams who will reach out to volunteers who will plot these locations. So there's tons and tons of information there available for free. You can go and download it. It's great. I add MassGIS here because they're actually surprisingly really good for map data, and they have a bunch of it available, and they made a lot of their data available to the OpenStreetMap team as well. Overture Maps is a new data set that is kind of coming onto the scene. It's being funded by the big tech companies. I don't recall who's all in there, but I want to say it's like maybe Facebook and I don't know, maybe Apple, or Amazon, I don't know. But a bunch of them are saying, hey, like we all use OpenStreetMap, but we could probably make a better whatever. So they put that out there, go crazy. And I also like USGS as taxpayers. It's super cool to be able to have a bunch of free data services out there that you can go out and grab. Data.gov, you can search for a bunch of stuff that's available. I love Pinball, so I want to point out this service. If you've never used Pinball Map, it's great. It has a great example of a variety of different services available in it. Obviously, they're pulling map data from, they're using Mapbox, which tends to be built on like OSM and things like that. Point data, geocoders to find out your stuff. Super great. If you like Pinball, check it out. I also put together this repo, GeoStarter. Basically, it has it has some Docker Compose set up, and kind of like a start. So if you want to make your own pinball map, I threw on there like a geocoder and some base maps, and you can draw features. It gets stored into a PostGIS database. You could play around with that and kind of use that as a good starting location to be able to do your own. To say, hey, what would this look like? Where would I put that? I use Django for it. Django is a Python-based web framework. Python is very popular because it has solid bindings for GDAL, and a bunch of data scientists use it. So it's fairly well documented, and that's, if you've never used Django, it's pretty great, to be honest. Again, it's really well documented. really well documented, really well opinionated, and it will get you most of the way you need to go. So in summary, definitely do geospatial, but don't roll your own. If you're doing it to build into your program, into your web app, or into your whatever, don't host your own data if you can, because there's a ton of it and there's tons of gotchas with it. If you're in it for the data, like if you're doing some research or you do want to pull something up, try to limit your scope. So try to find a data set that you like, and then try to narrow it down to just say Massachusetts. It will make everything a lot faster. It'll make things easier to store. Quicker queries. You can iterate a lot faster. I listed those gotchas. Definitely keep those in mind as you're going. And then I have some good examples here for how you can start. Again, not that they're necessarily the best in all cases, but in many cases, people. It's like saying nobody gets fired for hiring IBM or whatever. Whatever that saying is. It's kind of the same thing. Like if you pick these as your starting place to be like, that's fine. Like that, sure, makes sense. So that's about all I have for you. Any questions?
I got one, just seeing you tout the federal sources there, the NPS, I think. Are there any gotchas with IP in using geodata from places that the federal government?
Yeah, just like anything else, just like software or whatever, you always have to kind of look at the license. So like USGS, actually, they're like, yeah, you can use this for whatever you want to. Same thing, like for instance, OpenStreetMap, they have a it's I think they're under like kind of like a Creative Commons license. It's like they call it the OpenStreetMap database license or something like that.
Yeah.
It's pretty permissive. Whereas other services just no. You know, like you can't rehost the data or whatever. So yeah, you just have to be careful. But with the government services, they tend to be kind of like, yeah, as long as you point people back to it, like just say our name and we'll be happy.
Yeah.
Any other questions?
Are you a latitude, longitude, or longitude, latitude kind of guy?
Oh man, what a great question. I guess lat long. Yeah, I feel like lat long. It just rolls right off the tongue. And yeah, I mean, yeah, it was a hard thing because like as a computer person, like they want to do X, Y, and Z for everything, and so that's not the way we talk. We typically say like southwest, and that's But anyway, any other questions? All right, thanks everybody.
Thank you.
Yep.
Have a great day.